So yesterday we talked about how to classify triangles by their sides and by their angles. Today we're going to delve into what is actually happening with our angles. And the first angle relationship that's always present in every single triangle is the angle sum theorem. Okay, the angle sum theorem tells me that the sum of the measures of a triangle is always going to be 180 degrees. So when we look at it, it doesn't matter what it is, A, B, or C, it doesn't matter what type of angle triangle it is, acute, obtuse, or right or equilateral, A plus B plus C will always equal 180 degrees. Yes, sir. Angles of triangles. Thank you. Not yet. The homework is on my math lab, yes. But the notes are right there inside of it. Okay, and then the second angle relationship we're going to talk about is the exterior angle theorem. What does it mean for something to be an exterior angle? It's outside the triangle. And if I were to say an interior angle, what would you say? Inside the triangle. So an exterior angle. In this example, which angle, 1, 2, or 3, is our exterior angle? Okay, so this is my exterior angle. And then these guys on the inside have a special name too, and it's probably one you use all the time, but they are called, anybody know? Remote interior angles. Interior angles. Anybody want to guess why they're called remote? Not bad. So you're thinking about remote, that's fine. Second one on that wall, brother. Yep. Yesterday, after the test. I'm in here. All right. So the exterior angle is always equal to the sum of your non-adjacent. What's adjacent mean? Next to each other. We're not talking to you. Siri, she gets a little angry. So non-adjacent interior angles. We also call those our remote. So the measure of 1 equals the measure of 2 plus the measure of 3. So you guys are going to start liking this. We are on angles of triangles. Like I told your compadre back yonder, you just time traveled. You went ahead a full day. Angles of triangles. Yes, but they're on his 5 too. But yes, he will. Thank you. You're the man. All right, so we've only got 2 angle relationships. You guys are going to like this a lot more because it's just straight up math. Not all that pesky proven stuff. Yet. Okay, so number 1. I've got 2 known angles, and angle 1 is unknown. So what do I know is true about the total sum inside of that triangle? It has to equal 180 degrees. So how can I set that up mathematically? Guess and check. I don't like guess and check. There you go. 24. And then minus 180. 37 plus the measure of angle 1. So 24 plus 37, hey, we don't do that, plus the measure of angle 1, we don't, thank you, equals 180 degrees. So we're going to combine like terms on the left, 24 plus 37. Guys, y'all have calculators. There's no need to guess. 61 plus the measure of angle 1 equals 180. What do you want to do next? Subtract 61 from both sides. Thank you. And then 180 minus 61 is 119 degrees. And then what would I say by angles? What kind of triangle is that? Obtuse. Very good. What's that, brother? It would be scaling as well, yes. All right, number 2. Angle 1 is a what? It's an exterior angle. So what do we know is true about an exterior angle? The sum of the inside angles equals my exterior angle. So the measure of angle 1 equals 76 plus 52. $128. Hooray, not that bad, right?
So whenever it has an exterior thing, you do that.
Yep, when we've got an exterior angle, we're going to set up the relationship like that. Yep. All right, number 3. What kind of angle is 104? It's an exterior angle. What do we know is true about our exterior angles? They're equal to the sum of our 2 inside angles. This time, our unknown angle is one of our interior angles. We're going to end up subtracting. Yep. So I know 104, because that's my exterior angle, equals the sum of 79 and the measure of angle 1. And then we just got to subtract 79. We subtract 79. What is it? 25 degrees. Good. So the measure of angle 1 is 25 degrees. Now you're like, oh, coach, that's not too bad. Here's what messes up everybody's brains. When we start sticking triangles on top of triangles. For some reason, y'all's brains just go haywire on me. So what I want y'all to do is I want y'all to outline each individual triangle. Now you're going to have an overlap because you've got a shared side, but we're going to outline the triangle on the left. Come on, Sean. We're going to outline the triangle on the left, and we're going to outline the triangle on the right. Just so I can maybe help myself visualize what's happening. Okay. And then there's really a third triangle, right? You don't think so? The big one that surrounds everybody. What's that? And there's a line in between them. All right, so here we go. So we're going to find the measure of angle 1 in the green triangle. So in the green triangle, do we have to use exterior angles or our triangle sum theorem? How come? Well, that's a good reason. It's not outside, right? But if I've got two angles and all I need is the third one, I can use the triangle sum theorem. So what would that equation look like for the green triangle?
Why wouldn't it be exterior?
So angle 1, is that inside the green triangle or outside of it? So that's why it's not an exterior one. Yep. $56 plus 84 plus the measure of angle 1 equals 180 degrees. Does everybody agree with him? Yeah? All right. Combine like terms on the left. 66 plus 84. 150. Subtract 150 from both sides. So the measure of angle 1 is 30 degrees. All right. Now we need to go after angle 3. We've got a couple of ways we can do it. We can use something we learned from last unit, or we can use exterior angle theorem. It's up to you. Or do you want to see both? Okay, so let's do exterior angle. So if we're looking at angle 3, what would the two non-adjacent angles be? What is it? So what does adjacent mean? Next to. So is 84 next to 3? Yep, so we can't use 84 because it's adjacent. We need the ones that basically aren't touching it. So we need 66 and 30. Well, because why? We're using the exterior angle here, yeah. So we know the measure of angle 3, which is an exterior angle, is exterior for which triangle?
The red one?
It's inside the red one,
No, it was,
but it's, thank you, outside the green one. So the measure of angle 3 equals what? What do you think? 66 plus 30. Okay, and then we add those together and we get 96. Fantastic. And just for fun, what thing would I perform from last unit that would allow me to solve for 3? Not quite substitution. Are you done? Thank you, ma'am. So 84 and 3 are on the same line, being cut by a transversal. Linear pair theorem. I can also use the linear pair theorem. What does the linear pair theorem tell me? Oh boy. The sum of my two angles are supplementary. So 84 plus the measure of angle 3 equals 180. And then when I subtract 84, what do I get? 6. What do we get when we use our triangle sum, our exterior triangles?
96.
96. So either way, we can get the same answer. Guys, the linear pair and the vertical angle theorem are going to be huge pieces of this unit. They're going to show up a lot. All right, and now all we got to do is find angle 2. How am I finding angle 2?
At 96 and 43.
Yep, which theorem is that?
I don't know. Addition, cost,
Triangle sum theorem.
Yeah.
Triangle sum theorem. And that tells me that the inside of my triangle adds up to be 180 degrees. Yes, sir. Okay, so he says the measure of 2 plus the measure of 3, which is 96, plus 3 equals 180 degrees.
No, I never said that.
You didn't?
No, I didn't say that. Never mind.
I thought so.
I did.
I'm pretty sure this is what you said. Okay. Good talk. Protein shake.
Yeah, but no, I normally just don't put the little angle doohickey in there.
The angle doohickey.
Yeah, the 2. And I just don't say it equals 180.
Oh.
And then I just say, hey, I'm going to add 96 and 43. You know what
Okay.
I do? I add them together, then I subtract 180, and then there's my answer. It's just a lot easier for me that way, Coach.
So you said you add them together and then subtract from 180.
Yeah.
All right, let's see what we do.
Well,
All right.
hey, don't make fun of me now.
I did not.
You're going to add them up and then subtract them.
I did not make fun of
I
you.
wouldn't write it out.
But why not?
Because it takes way too much time.
Does it?
Yeah.
Aren't we just adding them together and subtracting them?
No.
Okay. So we're going to add together 96 and 43.
Okay, you don't got to announce it.
So what 96 plus 43? 139? Thank you. All right. And then once I write that down, I'm going to subtract my sum from both sides. So the measure of angle 2 is 41. Awesome.
I'm kind of confused.
What you got?
Like whenever it says, on angle 1 or whatever, like which one they use to find the.
So if there's two angles, we're going to go triangle sum theorem. So if you already know two angles in your triangle, so if I already knew 66 and 84, I'm just going to go triangle sum theorem because that's the easiest one to do. I don't have to do any extra thinking. But once I got over here to this red feller, now I'm missing two angles.
So I have to know what angle 3 is, just both angles.
So I would need to know angle 3, or I would need to know angle 2 to be able to find one or the other. It depends on what we got. So that's why we went with angle 3.
How are we supposed to know, like, which one to have? Like, how would I know that I had to do angle 3?
So if you didn't know angle 3, you could have done the exterior angle theorem on 2 the same way we did it on 3.
Thank you.
Yep. Hey. All right, number 5. 1, 2, and 3 again. So let's outline our triangles. I've got the green guy. Then I've got the red guy. Oh, Peter. There you go. So I've got my green triangle and my red triangle. So which one do you think we should go for first? Why angle 1? Do I need to do the exterior? So I know 2 angles, so I'm going to use those. Triangle sum theorem, yep. Because there's no exterior for the green. We're just dealing with what's inside. Sure. All right, so the measure of angle 1 plus 90 degrees plus 3 degrees equals what?
130 degrees.
Almost 180. Okay. The inside of a triangle will always add up to 180. So when we combine like terms on the left side, 90 plus 43 gives me 133. And then we're going to isolate angle 1 by subtracting 133 from both sides. Even if you're trying to do it the fast way, you're still doing what we're doing. So the measure of angle 1 equals 47. Okay, so which one do you think we should go after next?
43.
Okay, so how would we do 3?
Exterior 43. And could we use the exterior of 12?
You could. What you just said will work, but 3 isn't the exterior angle. Which would the exterior angle be if you want to use that?
Right.
43 is the exterior angle that we would add 3 and 12. That will work. So how would I set up that expression? 43 equals, because that's my exterior angle, 43 equals 12 plus what? The measure of angle 3, absolutely. And then to solve for angle 3, we're just going to do what? Subtract 12 from both sides. Yes, sir. You could. Hopefully. Let's find out. So 43 minus 12?
31.
So the measure of angle 3 equals 31. Then you did something wrong.
How do I know which one to put in front of the equal sign?
The exterior angle always goes in front of the equal sign because 12 is inside the red. Yeah, they just didn't have enough room to write 12. Oh, I got you. So you said you did 2 as an exterior angle for the red one. So how did you set yours up? If you were going 2 as my exterior angle to the green triangle, he went 90 and 47. Yeah. So 2 is outside the green triangle, and the 2 remote interior angles are 90 and 47. So it would be the measure of angle 2 equals 90 degrees. Degrees. And what's it give me? 137? And that be it. Let's look at number 7. Because 7 has something you guys missed on the test. Not all of us, but some of us. All right. So BC bisects ACD. What does it mean to be bisected? Cuts it in half. And if the measure of ACD is 90, and that rascal was bisected, what does that make each angle? 45 degrees. So 2 is 45, and 3 is 45. They just made y'all's life so much easier. They really did.
Because you made our life easier.
Nope, they did. They did it for us. So the measure, so again, y'all want to outline our triangles? You say no. Take that, Sean.
Fine. Well, you talk to yourself.
I'm always talking to myself. I mean, it's just you guys watching them. It's not like random people are watching the videos. They could be trying to learn math. But I doubt it. All right, so we've got a blue triangle and a green triangle. By putting that bisected measure, what'd they do for us?
Made 2 triangles.
Yes. But it just made it 2 triangle sum theorems. I don't even got to worry about trying to find an exterior angle, do I? I ain't not. So for the blue one, how would I set up that equation? You know, where we add them and subtract them from 180.
Angle 1 plus 45.
Oh, Peter, that's a big old fat marker.
180 degrees. Whoa.
The measure of angle 1
That was right, Cole. You didn't wrap your head around it.
plus 48 plus 45, hey, equals 180. How you write the thing on the left doesn't matter. Combine like terms, 48 plus 45. What do you think? What do you know? 93? No, Peter. Equals 180. And then we're going to subtract 93 from both sides. So the measure of angle 1 is 87. For the green one, how are we going to set up our expression? Yeah, we're finding angle 4 now. Measure of 4 plus 45 plus 83 equals 180. Combine like terms on the left, what do I get? 128 degrees equals 180 degrees. Subtract 128 from both sides. You know, just add them together and subtract it from 180. So the measure of angle 4 is 52. Now, let's throw another wrench in there. We're going to do 12 and 14. I don't want to do number 9. Yeah, but that's more of an honor thing than you guys. You won't have 4 triangles with a triangle. Look at 12. Solve for x. Them slippery rascals put variables everywhere.
Is this kind of adding what we did, like,
No, not really. It's just algebra. So what do I know? So before I even try to plug in what they gave me, I know that the sum must equal 180. So D plus the measure of E plus the measure of F all need to add up to be 180 degrees. Do you guys agree? Yes. Triangle sum theorem says that the sum of those 3 angles must equal 180. So now let's go ahead and substitute those values. Okay, so if I were to substitute the measure of angle D, what would it be? What's the measure of angle D? 5x minus 2. What about the measure of angle E? 9x plus 3. What about the measure of angle F? 11x minus 21. Oh, Peter. And that equals 180. So we're going to do what now? Why? We're just going to combine like terms. We're going to add our x's to our x's. And we're going to subtract, and we're going to add our constants to our constants. So 5 plus 9 is 14. 14 plus 11, 25x. Negative 2 plus 3, negative 1, or positive 1, sorry. And then positive 1 minus 21 is negative 20. So what do we do now? Add 20 to both sides. So 25x equals 2 stacks. Divide both sides by 25. So x becomes what? Great. We know what x is. Now what do we need to do with that information? Plug it in, plug it in. So 5 times 8 minus 2. 5 times 8 is 40. 40 minus 2 is 38. 9x plus 3 becomes 9 times 8 plus 3, so 72 plus 3 is 75. And then our last one, 11 times 8 is 88. 88 minus 21, 67. Boom. Look at you guys go. Yep, now we're going to do 14. Because 13 is just what we did on 12. Is that all right? Okay. Yes, sir. You can always go check my completed notes. It'll be on there for you. Okay. All right, so we got, before we even just try to plug and play, what is happening in number 14? What do we got going on? So I've got an exterior angle and then my two remote interior angles. So am I using my exterior angle theorem or my triangle sum theorem? Exterior. How would that equation look? Nope, before that. Before that. The measure of angle BCD equals the measure of A plus the measure of B. You did it again, you dummy. All right, what is the measure of angle BCD? (18x minus 15). What's the measure of angle A? (13x minus 11). And what's the measure of angle B? (4x plus 1). So we're going to leave the left side alone for now because there's nothing we can do over there. What can we do on the right? We can combine like terms. So 18x minus 15, 13 plus 4, 17. Oh, look how nice the math world is to us. And then negative 11 plus 1, negative 10. Anything else we can do on the right? Nope, so we got to start isolating our variable. What do you want to do first? I'm going to subtract 17, but all the things you guys said was not wrong. So I get x minus 15 equals negative 10. Now we can do what you wanted to. Add the 15. So x equals 5. Now that we know what x is, we can plug it in. So 18 times 5 minus 15. Anybody got 18 times 5? 90. 90 minus 15. 75. Now we got 13 times 5, which would be 65 minus 11, 54. And then angle B is 4 times 5. That's a nice friendly one, huh? 4 times 5 is 20. 20 plus 1 is 21. All right, your homework is on the math lab. Let me go ahead and create that. Yes. We're about to do that right now.